All right, so to solve the quadratic equations from our factoring unit test, number 9, easiest way to do this one would have been to factor it. So you would have set it equal to 0. And this was a factorable trinomial. So you set up 2 sets of parentheses, and you have to figure out what numbers multiplied to negative 22, but the numbers also had to add to positive 9, which would have been a positive 11 and a negative 2. So then you do your t-chart and make your mini equations by setting each of those parentheses equal to 0, and then solve for m. So your 2 zeros were negative 11 and positive 2. If you chose to do the quadratic formula, your work would have looked like this. Again, it had to be set equal to 0, so you should have subtracted the 22. So then you could have identified that A was 1, B was 9, and C was negative 22. So if you plugged in to the quadratic equation, it would have looked like this. So then when I simplified under the radical, I got 169, which if you checked using your calculator, it is a perfect square. The square root of 169 is 13. So again, you would have done a t-chart and gotten negative 9 plus 13 divided by 2, which would be 2. And then you also would have done negative 9 minus 13 divided by 2, which is negative 11. Same thing we got when we factored. Now number 10 is not factorable, but it's set up perfectly for completing the square because you have the 2 letters on the left, whole number on the right. So you would have taken your middle term, cut it in half, and then squared it. So I get 36, and you add that to both sides. And remember, you do that because now you have a trinomial right here that is factorable. So you would set up your 2 parentheses, or actually you only need 1, remember, and it would be just x plus 6. And we just write it squared rather than writing out twice. So then you square root, and you get x plus 6 equals radical 27. Subtract the 26 over. And then you can reduce that radical. Radical 27 can go, the perfect square 9 can go into that. So I can break it up into radical 9 times radical 3, which the square root of 9 is really just 3. So that turns into that. So final answer would be negative 6 plus or minus 3 radical 3. Again, if you don't like completing the square, you can always use the quadratic formula. So if you're going to use the quadratic formula, you have to set equal to 0. Then you can identify the A, the B, and the C. And then you can plug in to the formula, which remember is negative B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. Which, if you then go and simplify under the radical, you get 108, which can be reduced with 36 times 3. So that really just is 6 radical 3. So if I put that in the spot where the radical was, I can then reduce even more because my 2 whole numbers on top are both divisible by 2. So that would turn into negative 6 plus or minus 3 radical 3, just like we got when we did completing the square. Number 11. First things first, you should have distributed. Then set equal to 0. So I'm going to subtract the 2x, and then these right here make 6, so I'll subtract 6 from both sides. So you'd get minus 1x minus 6 equals 0. And that is actually factorable. So if you set up your two parentheses, you're figuring out what multiplies to negative 6 and what adds to negative 1, which would be negative 3 and a positive 2. So then you can do your t-chart and make your two mini equations by setting each parentheses equal to 0. So your two zeros would be a positive 3 and a negative 2. And the question asks, what's the positive 0? So they were looking for that x equals 3 there. Now, if you do not like to factor, you could have you would have done the exact same thing starting off with. So you still would have set it equal to 0. You would have ended up getting that again. But use the quadratic formula. A would have been 1, B would have been negative 1, C would have been negative 6. Plug in, it would look like this. So then you get a positive 1 plus or minus radical 25, divide by 2, which 25 is a perfect square, so you would have done a t-chart. So it would have been 1 plus 5 divide by 2, which ends up being x equals 3. And then 1 minus 5 divide by 2, which ends up being x equals negative 2. And again, they are looking for the positive number, same exact answer. Number 12, you should have started off by cross multiplying. So x times the x plus 4. And then equals 3 times the 8. Though when you cross multiply, it's perfectly set up again for completing the square. So you would take the middle term, cut it in half, and square it. So I'm going to add 4 to both sides. Factor this side, you end up getting x plus 2 square root move the 2 over, and then you actually should reduce radical 28 because 4 can go into radical 28. So off to the side, I can break this down into radical 4 times radical 7, which is just 2 radical 7. So final answer is negative 2 plus or minus 2 radical 7. If you, again, do not like any other method and you still want to stick with quadratic formula, again, when you cross multiply, you're still going to get the same thing. You're going to have to subtract the 24 over to the other side. So your A would be 1, B is 4, C is negative 24. Plug in would look like this. So simplify under the radical. You would have gotten radical 112. And that can be broken down into 16 times 7, which is really 4 radical 7. So you get negative 4 plus or minus 4 radical 7, which can be broken down even more because both of the coefficients on top, the whole numbers, are divisible by 2. So you get negative 2 plus or minus 2 radical 7, just like the other answer. Number 13. This one, probably the best method would have just been to do the quadratic formula. So A was 1, B is 0 because there is no x term, and C would have been the negative 112. So plug in. simplify under, you would have gotten 448, which could have broken down with radical 64 times 7, which is really just 8 radical 7. So plug that in. And both of your numbers on top, those whole numbers, are divisible by 2, so it can divide to become 0 plus or minus 4 radical 7. All right, 14. 14, it's not factorable. You've got a number in front, so again, 14, I probably just would have done the quadratic formula. So A equals 2, B equals negative 20, and C equals 16. So plugged in, remember it's negative B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. So if you simplify this, you would get 20 plus or minus the square root of 272 divided by 4, which 272 can break down with radical 16 times radical 17, which is just 4 radical 17. So if I plug that in, I can simplify this even more because now the two whole numbers on top are, that should be a 4 on bottom, are divisible by 4. So it turns into 5 plus or minus 1 radical 17. 15, this one was factorable. If you set it equal to 0, it is just a greatest common monomial question. Both of those two terms have an x in common. So you could have taken out an x and you would have been left with x minus 5. And then just on a t-chart, set each of these pieces equal to 0. X equals 0, so there's one answer. And then x minus 5 equals 0 just turns into x equals 5. If you, again, don't like any other method and you wanted to do the quadratic formula, again, it would have had to been set equal to 0. So then A and B is negative 5, and then C would have been 0 because there was no whole number on this one. So if you plugged in, it would have looked like this. So simplified, you get 5 plus or minus radical 25 divided by 2, which that is a perfect square. So you would have done a t-chart, and you would have had 5 plus 5 divided by 2, which would have been x equals 5. And then 5 minus 5 divided by 2, which would have been x equals 0. Same answers. And then last but not least, 16. Again, it's not factorable, and since you've got a number in front, might as well just do the quadratic formula. So A is 2, B is negative 16, and C is 10. So the formula is, remember, negative B plus or minus the square root of B squared minus 4 times A times C, all divided by 2 times A. So this simplified would have been positive 16 plus or minus radical 176 divided by 4, which you had to simplify the 170. And that breaks down with 16 times 11. So that's really 4 radical 11. So if I plug that part in, I get 16 plus or minus 4 radical 11 divided by 4, and you can go even farther because both of these numbers are divisible by 4. So you get 4 plus or minus 1 radical 11.